and we get to finish our chapter out finally with the law of cosines. Co is fancy for like more than one. Like if you played co-ed softball, you're playing with more than one gender. And like I said last time, sines kind of sounds like the word sides. So in this triangle right here, can you see they gave me more than one side length? And it's not a right triangle, right? If it was a right triangle, we would use SOHCAHTOA. SOHCAHTOA is so much faster than this. So here's what we got right here. Like this law of sines, I kind of made this formula up. Like the B and the C are definitely in your formula that you would read in any math textbook, but they won't have this little x and big X. What are the B and the C? They're the two sides that you know, right? They're the sides that they gave you, but I changed these other letters to X's because in math, most students are pretty comfortable solving for X. So these are like possibly what we're looking for. We can't be looking for both at the same time. So if it's a little x, remember how little x's are like side lengths, and if it's a big X, that would be like an angle measure. So if we kind of check this guy out right here, the reason why I have those is because little x and big X are always across from each other, just like little a is across from big B, little b is across from capital B, kind of thing. So what we got going on here is we have the law of cosines, and I'm looking for a side length, so that's going to be little x. So just hang with me on this, and as we do more, they'll get easier. So little x, we don't know. B and C, those are the two side lengths. It doesn't matter which one's which, so they get squared right here. So do you see how it doesn't matter which one's B and which one's C? They're just those two dudes, right? And then they're going to subtract away 2, and then if I use parentheses, life's going to look a lot cleaner for us. 2 times 12 times 14, so we'll put those in parentheses. But it's also times the cosine of big X. Well, big X is the angle measure across from little x, and in this case, it is 62. So that's the hard part in phase 1, is when you're not used to it, it's like, how do I even set this up? Remember, this formula is on your yellow card, so you could use it. And then I got a cheat for us. To make this a lot easier, here's what we'll do. Please, please, please draw a box around this right here and draw a box around these guys right here. And if we figure out what's in that box, holy cow, will life be easier. So I'm going to bring everything down. This x squared comes down, and then in that first box is 12 squared plus 14 squared. So 12 squared plus 14 squared. We just get 340, so 340 comes down. Then a minus is still there, and then there's another box, so 2 times 12 times 14. Just punching that in. That is 336, 336, but he's got a cosine of 62 with him. And that right there means you just can't subtract those. It's so tempting to try to subtract those from each other, but because that guy's got a cosine of 62, that's like taking like 3 minus 2x. Like you don't get to call that just 1x because those aren't like terms. These guys right here are not like terms. So we just cleaned up the mess a little bit. But you see, over here, we're looking for x. He's basically all by himself already, except that he's getting squared, right? So who cares? I just need to figure out what this number is. So I'm going to go to the calculator and just punch that big hog in. And it's a lot easier than punching all that stuff in. Trust me. So 340 minus 336 cosines of 62. Oh yeah, why did we use cosine? Because this guy's called the law of cosines. So if I get that, here is this big old nasty number right here. That's actually not what we need, but we're going to write him down. So x squared is basically, hit the wrong button here guys, 182.25, 182.25, dot, 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 dot. It's this really long, nasty number, but you see, we haven't solved for x yet. Don't we need to square root that, guys? So what I'm going to show you, you've probably seen before, but I'm going to use the previous answer button. So I'm going to hit second square root, so it's going to ask me to square root something. And then a lot of people go up and copy and paste that number. You can't do that, right? You need to use the entire answer. It's been rounded off to like 7 decimal places there. If you hit your ANS button, which mine is way down by my equal sign above the negative symbol, I'm going to hit previous answer. That will square root that dude right there. And that's what I'm looking for, about 13.5. So x was about 13.5. So we'll sub in, we'll clean up what's in the boxes, and then we'll write this long little bad boy of what x is, x squared is, and then we'll square root him, 13.5 approximately in that case. Let's try that again. First, let's talk ourselves through it. This is definitely not a special right triangle. He's not 30, 60, 90, or 45, 45, 90. He is not even having 90 in it, so I can't use SOHCAHTOA. It's down to the law of sines or the law of cosines. How do I know which one to use? It's about how many sides they give us. More than one side means more than one sine, so we'll use the law of cosines. And we are looking for this right here. He is a side length, so in my little formula, he is a little x, and that 82 right there is a big X. So let's substitute in. Little x squared is going to equal, B and C are these two pink side lengths. It doesn't matter which one's which. It's all going to be good in the neighborhood. Minus 2 times 20 times 25 times the cosine of that big X, which is that 82, right? So then, please, please, please trust that we're going to put what's in the boxes here and clean that up. So this x squared comes down. We'll go get 20 squared plus 25 squared. That is 1,025. Take away 2 times 20 times 25. So that's 1,000. But that cosine of 82 is still with it. Nope, you can't subtract those guys because that violates the order of operations. You got to just realize that there's a multiplication going on right there, and that messes up subtraction's order. So we'll just go punch that in. 1,025, take away 1,000 cosines of 82. And that's going to be a nasty boy. We'll write that nasty boy down, 885.8-ish. So that's what x squared is 885, right? 0.8-ish, and then dot, 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 dot. I do want you to put those dots, right? Why? Because we need to square root both sides to, like, figure out what that's going to be. And those dot, 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 dots tell me you didn't round that guy off. If we hit second square root, and then use the ANS button to go to our previous answer, we've never rounded that guy off, and it's about 29.8. That's what we can round off is the final answer. So about 29.8 units long is how long that bad boy is going to be. But that's when you are missing a side length in this situation. Check out this. Holy cow, they gave me all 3 sides. So it's not just about having 2 sides, it's about having more than one side. I have no angle measures whatsoever in this triangle, so I can't do special right triangles, can't do SOHCAHTOA, and I can't do law of sines either. I have to do the law of cosines because I have more than one side. And that's why I made up this little relationship. They are wanting us to find this, and we have to be smarter than the problem. I totally know that is a lowercase x. But isn't he an angle measure? He is big X, right? Because he is an angle measure, he's a big X. And little x is this guy, the side across from him. He is the most important side because he's got to go right there. So the 10 has to be that dude. And then your B and your C, those are the other 2 dudes who have nothing to do with this angle relationship being across from it. So the 10 and the 11 are the guys that are like, meh, it doesn't matter which one's which. So minus 2 times the 11 times the 12 times the cosine of big X. Why is that a big X? Because he is a missing angle measure. And can you tell this one's different now than the first 2? But if you trusted me with this box thing, it's going to make life a whole lot easier. So we're going to do a little bit of cleanup. first, this 10 squared, you could punch that in if you need to, but I hope you know 10 squared is 100. Didn't even punch it in right, but I got it right there. So that's a 100 equals, figure out what's in the box. It's 11 squared plus 12 squared. Struggle busting here. 265. Take away 2 times 11 times 12. It's in the box. But that 264 has a times cosine of big X with it. And what I'm about to show you, I'm going to do some work side by side here just so you can kind of see if this equation right here just said, I'll do it in blue, 100 equals 265 minus 264x. Do you see how these two equations are almost the same thing, except this is cosine x and that's just x? You totally know what to do to solve this guy right here. You get rid of this first. Like, you cannot add or subtract those together because they're not like terms. That has an x with it. So we're going to subtract 265 from both sides. So 100 take away 265 is going to be a negative 165. So, like, look at this. This would be like the negative 165 equals negative 264x. Same thing here. It's going to be negative 165 equals negative 264 cosines of x. Like, check that out. You see the only difference? I just subtracted 265 over from both sides. So let's go back to our comfort zone of this blue one right here. Our next move would be to get rid of this times negative 264. You get rid of a times negative 264 by dividing both sides by negative 264. And here's what happens is you've got a negative over a negative, bro. That's going to be a positive. So what I say is we're going to get rid of the negative parts because it's a negative over a negative. And I just divided both sides by negative 264. And I could care less if that fraction right there reduces or doesn't reduce. I just think it's wise to not have the negative over the negative part, even though it's not wrong. It's like, why do that? It's a positive. And check it out. Going back from a couple times ago, we are looking for this. Isn't he the angle measure? Well, the way you find that is with the inverse. You can do the cosine inverse of these guys. So those will switch places, right? So x is going to equal the cosine inverse of 165 over 264. And that's why I don't care about reducing that fraction, because we're just going to punch it in and get this weird decimal anyway. So the cosine inverse, remember, if you hit second cosine to get that minus 1 little guy right there, what was it? 165 over 264. Close those parentheses up. And this is an angle measure, and up in the instructions it says round these to the nearest degree. So that's either 51 degrees or 52 degrees. We'll call that about 51 degrees because that guy was not 5 or larger in that case. So that's pretty wild right there. And I can tell you from years of experience, if you do this stuff in the box, it makes life a billion times easier. So let's try another one of those. You see here is a triangle. He is not special. He is not a right triangle. I don't have any angles in it at all. I do have, though, 3 side lengths, and they're asking me to find an angle measure. So since I have more than one side, I will use more than one sign and do the law of cosines. This guy right here is big X. He is an angle measure, and I care about who little x is. Little x is the side length across from him. So 16 is going in for little x, and then 18 and 24 are your B and your C. It doesn't matter which one's which. Then times the cosine of big X, which is unknown, right? Again, people ask a great question. How do you know it's cosine and not sine or tangent? Because this guy's name is the law of cosines. So it'll always be. And if you put what's in the box right here, boom, boom, life will be a lot easier. So we'll clean things up. 16 squared, go figure that out. 256 comes down. 18 squared plus 24 squared. Nah, I forgot a plus. Sorry, guys. 18 squared plus 24 squared. Didn't square it. Holy cow. 18 squared plus 24 squared. 900. Sorry for the delay. 2 times 18 times 24 is 864. And that'll be times the cosine of big X. So here's what we're trying to do. We're trying to get this all by itself first, right? He's the guy with the X in it. There's this stupid plus 900 hanging out with it. I need to subtract 900 from both sides. And if I punch that in, 256 minus 900, I get negative 644. Don't freak out that he's negative. He actually better be negative, because this guy over here will always be a negative times the cosine of x. And we will divide both sides because there's multiplication going on between those. So 644 divided by 864. Notice I did the negative over the negative and made him positive right away. It's like, dude, that totally reduces. Who cares? Because we need to solve for this angle measure, which is time for the inverse. X will equal the cosine inverse of 644 over 864. We go punch that in. The cosine inverse of something, 644 divided by 864. Bada boom. About 41.8, so they said round to the nearest degree. That's about 42 degrees. About 42 degrees, approximately, on that one. That's the law of cosines, the messiest of all of them. But if you do what's in the box, it's not that bad. So let's see here on the back side of the story problem. Surveyor would like to know the distance across a small lake. So that surveyor is standing right here at point O. They have a cool bit of technology that will allow them to see a distance right here of 600 meters to a certain stake right there, and she sees another distance of 1,400 meters right there in some surveying equipment, and she knows it's a 76-degree angle because the technology she's using totally tells her. Why did she put these points right here? Because they're not in the lake, and she can go put a stake in the ground and survey to that spot. So what we'll realize is she's looking for the distance across the lake, which we'll call that x, and we'll decide if we want to use special right triangles. Nope, don't have 30, 60, 90 or 45, 45, 90. Can we use SOHCAHTOA? Nope, I don't have a 90. Law of sines or law of cosines, that's about how many sides they gave us. And we know more than one side, right? So that's going to be the law of cosines. Who the heck is this? Is he a little x or a big X? He is a side length, so he is little x. And then the 1,400 and the 600 are B and C. And this is going to get big numbers here due to the fact that we got to square those times the cosine of 76. Check my setup out and see if that makes sense to you. So then right there, we'll figure out what's in these boxes. So x squared is going to equal 1,400 squared plus 600 squared. That's going to be big. Whew! 4 zeros. So 2, 3, 2, and 4 zeros. 2, 3, 2, 1, 2, 3, 4. Go back and put commas every 3 spaces. That's a big number. Minus 2 times 1,400 times 600. 4 zeros again. 168 with 4 zeros. 1, 2, 3, 4. Go back and put commas times the cosine of 76. And then, since the x squared is all by itself, we don't need to move anything over or anything like that. We will just punch this in. So we'll do 2, 3, 2 with 1, 2, 3, 4 zeros. Take away 1, 6, 8 with 1, 2, 3, 4 zeros times the cosine of 76. We're just punching all of that in, and that'll tell us what x squared is. So x squared is about that big old number that I have written down right there. And he's still rounded, you know, like it's not exactly the 215. He's still rounded. They can only fit 3 decimal spots on it, though. So you jot that bad boy down, go back every 3 spaces and put commas. And that's not what x is. That's what x squared is. So I will second square root that previous answer. And there's where I'll get about, they say round to the nearest meter also in this situation, so about 1383. X is about 1383 meters in this case. And this totally happens in real life all the time. These are surveyors. They do the technology. They plant the stakes, and they use surveying equipment, which is laser guided, and it will do these measurements and get pretty stinking close in that situation. So then here we go. 2 cars start moving from the same location. Let's draw a picture of it, and trust me, we'll use a straight edge to make things nice, but just start with this little dot right here. This is where the 2 cars start from. Using a triangle shape on the geometer probably isn't the best on this one after years of experience, so we're just going to like use a straight edge. So 2 cars start moving from the same location. They head straight, but in different directions. So the angle between them is 43 degrees. So I'm going to roughly, we'll make a 43-degree angle when we do this. But check this out. I want to see how long these are going to be. The first car travels 20 miles, so sweet. And the second car travels 37 miles. That second car basically went twice as far. Not exactly, but twice as far as the other one. So watch this. In green, I'm just going to put like a segment for the first car going 20 miles. It's like, whatever. Boom. 20 miles. And then in red, which is pretty close to pink, I'm going to make a segment that's basically twice as long as that, right? Basically, and at roughly 43 degrees. So nothing perfect here, you know, but something like this, 37 miles, and it happened at 43 degrees in that case. So those 2 cars, one of them in green went this way, 20 miles. The other one went 37 miles this way, and they went apart at like 43 degrees. They say how far apart are the 2 cars? Well, that would be this blue distance right here. That is how far apart they are in this case. So they ask us that question. Let's see how we could solve this. It is not special. That's so close to 45, but it's not. And I wouldn't know that other guy is 90 or not either, so I don't know that. So he's not special. I don't have a right triangle, so it's down to law of sides or law of sines or law of cosines. How many sides do I have? More than one. So we will do the law of cosines on this one. This is little x, and that is big X. Why don't you get him set up and see if you can punch him in. So here is my setup. It's always the same with the law of cosines. Then I put my box around those 2 guys and figured out what was in the box. I got 1769 in there and 1480 in there. And then you can just punch this whole part in the calculator. You don't need to undo anything because what you're looking for is basically already all by himself on one side of the equal sign already. So when I punch that in, I got 686 point blah, 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 blah. You still need to square root both sides with your previous answer, but then I got about 26.2 miles back on that bad boy. And then the last one, baby, they ask what's the best way to solve. These will be test questions also, so you'll have to pick. Here is a triangle. Pythagorean theorem needs a right angle in it, so I won't do that. Special right triangles, nope. SOHCAHTOA needs a right angle in it also, so it's not that. It's down to the law of sines or the law of cosines. It's all about how many sides I know. I know one side, so we will do the law of sines. So again, I circle the side and draw an arrow to the angle across from it. So the sine of 123 over x will equal, this guy right here is the other side. Got to figure that out. So I'll do that in my calculator off screen. 180 minus 123 minus 43. I got 14 degrees. Little boy. So the sine of 14 over 9.6. And remember, we solved those with cross multiplication. So 9.6 sines of 123. Did a little cross multiplying there. equals x times the sine of 14. And then we will divide both sides by the sine of 14. And punch that in one thing at a time, right? I'll do the numerator first. So that is 9.6 sines of 132 divided by, delete, and then divided by the sine of 14. And I got that to be about 29.5. So about 29.5. So that's it, baby. Law of cosines. Looks messier than it actually is, but let us know if you need some help with it. Have a good one.